Cisco's SDN is the application-centric infrastructure, ACI. We are going to focus on this data center fabric technology called ACI. What is Cisco ACI? Cisco application-centric infrastructure is a SDN, software-defined networking solution. What does it do? It automates and makes things easier in a data center network. What does ACI provides? A centralized policy-driven architecture. Yes. We are not going to go to each and every devices like routers and switches. We are going to have it as a centralized policy-driven architecture. You don't need to go to every hops. We are going to have a centralized orchestrator using which we are going to define the policies for each data plane for every device, for each device. That's why it is policy-driven architecture. We define the policies for each device and push it, deploy it. Not only that, this can provide an enhanced security, fabric-wide security, also segmentation. What do we mean by segmentation? Isolation of a big network. By dividing into small networks. Each small network is a segment. Each small segment is independent. There is a total isolation between the segments. In another word, we have multi-tenant. Segment is nothing but tenant. One tenant may be an organization, or one tenant may be a department. Isolation between organizations. You have one shared pool of resource for multiple organizations. Each organization will have a segment, which is nothing but a reserved resource pool. And the ACI also provides automated network provisioning. As I said earlier, when a device is attached, immediately ACI will say, if this is what identified in this device, this is the policy. For example, a device is attached to VLAN 10. For all the devices in VLAN 10, this is the policy. What policy? He cannot talk to HTTP server, but allowed to do SSH. So those are all what? Provisioning, automated network provisioning. So we define this policy beforehand for all the devices that are going to be connected to the ACI fabric. When such devices are connected, the policy is taken. Like we have a lot of laws already defined in the country. When a crime is committed, that law is enforced. The corresponding law for the crime for the crime is enforced. So law is defined beforehand. Law is given by God. And every country taken that law that is given by God, altered it according to their own understanding. And every country has got laws. Yes, it is good to abide laws. When we violate, policy will be applied. If this is the violation, this is the penalty. Likewise, when a device is attached, that device is identified with some ID, maybe the device IP address, the device VLAN, or can be any ID you may use to identify the end devices. When the device is matched with some identity, the policy is immediately enforced. For example, in ACI, we divide in domains. We call it as domains. VMM, router, switch. So when a router is attached, the necessary data plane is provisioned automatically. When a virtual machine is attached, the necessary policy for the VM is pushed. So this ACI can be deployed, integrated with both physical as well as the virtualization network, virtualized network. Now, this table column defines the difference between the traditional data center network and Cisco ACI network. First, for the configuration. On the traditional networking, we used to go to each device manually and configure the policies manually using CLI. Because we need to do everything manual, and scalability is not that scalable, because when we have the three-tier architecture where we have access, distribution, and core, there is a big issue with the scalability, because every layer in the three-tier architecture carries different type of traffic, not the same type of traffic. When you have different type of traffic, then you will have different type of policy for each layer, which is impacting the scalability. Whereas in Cisco ACI, if you notice, it's policy driven and it is automated, meaning the configuration, the policies for the attaching device, everything is automated. And the Cisco ACI fabric follows the two-tier, not even two-tier, I should call it as leaf and spine architecture. And both leaf and spine works together in forming a single fabric, which is unlike the three-tier access, distribution, and core. Here you got one big fabric, end-to-end scalability is seen here. And the hardware, which is working as an underlay, and VXLAN acting as an overlay. Overlay helps you to have your own desired topology. ACI is not subjected to the physical limitations because it's VXLAN, it's tunnels, the virtual circuits that forms topology here. In traditional network, it is a physical topology. So there are limitations to the physical hardware. Here, though we have underlay as a physical hardware resource, we don't write policy on the hardware. Rather, we create an overlay circuit, overlay virtual topology. To that virtual topology, we write policy. So no limitation, highly scalable. We are writing policy to the overlay, which is not physical. Physical network have got limitations. Overlay is created using a big resource pool, the physical resource pool, and physical resources hidden for the policy. All that policy sees is the overlay. That's why VXLAN is highly scalable with VXLAN. Sorry, Cisco ACI is highly scalable with VXLAN overlay. We learned VXLAN. Security wise, here we used to give security based on VLANs in traditional network. Here it is micro-segmentation and contract, meaning we are going to learn what is contract in today's class later. So we are going to have micro-segmentations like tenants, VRFs, bridge domains, endpoint groups, bridge domain. We will have IP, we will have VLAN, subnets, all this segmentation. And we'll write contracts for those segmentation segments, micro segments, not just VLAN based segment. So this is more granular security. Automation, if you see, it's very less in traditional network, very less automation we do, very less scripting we do. Whereas ACI is fully automated. There is no need for you to configure anything using CLI of Epic. Epic can be accessed via CLI as well as web-based, but you don't need to use CLI. So as we just saw, the scalability is there because of the leaf and spine, leaf and spine, or spine and leaf architecture which ACI uses. Understanding spine and leaf architecture. In traditional, we have three-tier networking design called access aggregation or distribution and core aggregation and access. Whereas we have here in ACI spine and leaf topology, advantage is this, low latency. How? When you have access aggregation and core, as I said, access carries mostly layer 2 traffics. Aggregation combines layer 2 and layer 3. Core connects many segments. So you have here in different layer, different types of traffics and different policies for each tier. Whereas ACI is just a single fabric, leaf and spine, or spine and leaf fabric, single fabric, and from any leaf to leaf, you will see same number of hops, two hops, any leaf to any leaf. All leaves will be connected to spine, so you will always see only two hops from leaf to spine and spine to leaf. Just two hops, anywhere to anywhere. Whereas in traditional network, some will go up to core layer from access, some will be local within the access, some will go to aggregation and come down to access. You know, so the latency is not same. The delay is not same. For some traffic delay is less, for some traffic very high, some traffic medium. But in ACI, it's only single tier, so low latency. Not only that, predictable. Predictable delay. When the delay is predictable, then it is easy to adjust according to the delay, which is not possible if the delay varies time to time. For example, if your friend says, I'll be there at 5 o'clock, and if he always comes at 5:15, always 15 minutes late. If he says 5, he will come 15 minutes late, 5:15. If he says 8 o'clock, he will come by 8:15. If you know that he will always be 15 minutes late, now you can adjust accordingly. If he says 8 o'clock, let's go by 8:15. It's predictable delay. But sometimes he comes 5 minutes late, sometimes he comes 30 minutes late, sometimes he comes 20 minutes late. Then it is difficult for you. You have to go at 8 o'clock if he says 8 o'clock, because he may come any moment. He may come at 8:05, he may come at 8:02, he may come at 8:30, he may come at 8:55. We don't know, but he will come. Sometimes he comes on time, sometimes he comes late. That is difficult. Headache, you see, you cannot adjust. In three-tier design, it is difficult to predict the delay because it is varying for different, each traffic it is different. And as I said, this ACI is overlay fabric. So traffic forwarding is on the overlay topology, the virtual topology. So efficient traffic forwarding we can see. You are not subjected to any physical limitation. For example, no STP. In physical design, when you have redundant path, there is going to be STP limitations, like STP is going to block some of the ports. All right, the components of ACI. Number one, spine switches. Two, leaf switches. Three, application policy infrastructure controller. Three components only. . Now the spine is acting as a backbone of the fabric. Leaf is acting as the border, perimeter of the fabric. As I said, spine is acting as a backbone. Spine is not going to connect to any end device, any of the host. Spine is not going to connect to any of the host because it's a backbone of the fabric. Spine will be connected only to the leaves. All the leaves connects to spine on the top and the host at the bottom. We call the hosts as the endpoints. So spine switches need to be really fast because they are the transit device for all the leaves. Between the leaves, spine is always there. There is no direct leaf to leaf connection allowed. It's always through spine. So spine switch should be a high-speed backbone switch which interacts with all leaf switches. As I say, leaf switches are the one which connects to all the endpoints like servers, routers, VMs, switches, storage device, etc. And all the policy enforced on the leaf. No policy on the switch, spine switch. No policies are not enforced on the spine because there is no endpoint devices. There is no host connected. Servers, VMs, routers, switches, storage devices, all are the hosts connecting to the ACI fabric. They are only connected to the leaf, so policies are needed only on the leaf. What about the epic? Do epic connects to spine? No. Even epic also connects only to leaf. Epic is a controller. Epic is not a data plane, meaning Epic is not going to carry any of your data. Epic is just a controller, centralized managing interface, web interface, central controller managing the entire fabric. It's a C series server with the manager installed in it. The epics, I say epics plural. Yes, you will have always 3 or 5 epic for each ACA fabric, redundant epic. And this epic or the one which is going to direct the fabric, which is going to define the data plane on the ACA fabric. Which means Epic is going to provide the control plane for the fabric. It is Epic the one which is going to deploy the necessary control plane to each leaf, according which the data plane is going to be established. Now, what is the benefit of leaf and spine architecture or spine and leaf architecture? As we already spoke, you have a predictable delay. That is nothing but equal latency. Same delay, any device going from any leaf to any leaf. Device connected on leaf 1 going to leaf 10, leaf 5 going to leaf 20. Same time taken. That is what deterministic forwarding. Improved scalability and performance. How? If you want to add more endpoints, you need to increase the number of leaf. Add more leaf. If you want to increase the performance, then add spines. Add more spines to improve the performance. Add more leaf to increase the size. Add more EPGs, endpoints. And it's simplified network provisioning. How? You don't need to think about 3-tier architecture and policies for each tier, different QoS on different tier. Those complexity is no more here. Simplified network provisioning. So far good. Is there any questions so far? We saw what is Cisco ACI, the difference between traditional ACI and traditional network and ACI, the components of ACI and the benefits of leaf and spine. Now, ACI fabric discovery and initial setup. Let me get one picture for you. So in this picture, we see the spine on the top, a big size switch with more power, processing power. And we got a small switches kind of picture, leaf. Both are Nexus 9000 series ACI mode devices. And we also see 3 EPIC in the left, application policy infrastructure 1, 2, 3 for redundancy. And we also see endpoint devices, endpoints like VM servers, storages, L4, L7 service devices like load balancer, firewalls. We also have external network L3 out like routers. You can also have L2 switches. Now this is the overall picture of our ACI. Now let us talk about the ACI fabric discovery and initial setup. Like, this is the first time you're building the ACI, very first basic step to be taken. So you are provided with some spine switch, let's say 2 switches, and you got some leaf switches like 4 plus to 6 leaf switch and 3 epics. Now, how you are going to bring it up? First, you need to bring up the fabric. After only you can connect the end points to the leaf. To bring up the fabric, we have to connect like this. All the spines you see, they are connected to every single leaf. Both the spines have got a link to each leaf, which means each leaf have got 2 connections to the upstream spine. One to spine 1, another one to spine 2. And if you see the leaf, they also connect down the epic. There is a port called out of band management port on the epic, using which we have connected. We'll talk about the connection in the next page. But what I'm trying to say is epic are not connected to spine. This is the physical design. Epic is connected to leaf and leaf is connected to spine. Then how can I discover spine via leaf? Epic needs to first discover all these devices. All these devices can be discovered like this. This will discover this device and this device. After which it will discover this device and this device. And this device will discover this device, this device, this device, and this device through redundant connection. I'm going to do that. I'm going to show you. I'm going to show you. That is the epic server configuration. Very basic, very first step. Not much. We need to give some resource address pools and so on. I'm going to show you. But what I'm trying to say is epic will be first discovering the connected leaf, and once the leaf comes online by getting some names and IP address which we are going to discuss, that will discover the spine device which is on the top, and through spine all other leaves will be discovered. Step-by-step fabric discovery process. First, you connect the epic to the leaf switch. And then once the leaf is recognized by the epic, you need to provide a unique name for the leaf, like 101 hyphen leaf 1 or leaf 1 hyphen 101. It's up to you. You can give any name. And as soon as you give a name, an address from the predefined pool, who defines the pool? We only give. We only define the pool. From that pool, an address will be given to the leaf. Now the leaf gets active. And now that leaf will discover spine. And to the spine, you will again give a name and an address will be taken from the pool. And when you register all these devices after they all discover by getting a name and an IP address, it will reload and come online. And then you can go to GUI. Actually, these things are done in GUI only. You validate the discovery using the Epic GUI. We are going to see these things step by step now. First, we are going to see connecting Epic to leaf switch. Physically connect Epic to the leaf switch, not to the spine switch. Connect the Epic controller to the first hop leaf switch using fabric interface. Okay, means normal ports. On the switch, you have a normal data plane port. You just connect to that. Epics are never connected directly to spine switch. Now, on the epic side, connect the out-of-band management port of each epic to the management network, like switch or a jump server, for GUI or SSH access. This is for the management. I repeat, already you have connected epic to the leaf. That's a separate connection. You need another connection from the management port so that you can see things that are going inside epic through both SSH and GUI. But initially GUI won't be coming up. You need to go through SSH and do some initial setup, like we give a name, we give the pool for the tunnel endpoint address, TEP address pool. Then only the discovery will start and it will show you the first leaf and its serial number, to which you need to give a name, the fabric name for that switch, and an IP address will be taken from the pool. So first you do the physical connectivity to the leaf. The best practice is at least 2 epic. We saw in the picture 3 epic, at least 2 epic. We see here 3 epic. And don't connect both the connections to same leaf. It's useless. Connect to different leaves so that even if this leaf goes down, this epic server 1 will be still accessible via this leaf to discover. Even if you see the server 3 is connected to leaf 3 and leaf 4. So the best practice is use at least 2 epic. 3 is recommended. Even I have seen 5. Always connect each epic to at least 2 different leaf switch for high availability, which I just spoke. Ensure that the epic software, this is very important. Ensure that epic software version matches the ACI switch firmware. Otherwise, you need to upgrade to prevent compatibility issues. So you go and see the firmware of the ACI switch. Accordingly, you pick one epic software version. Those things are very clearly described in the datasheet in Cisco's documents. Secondly, see, we have just connected the physical wires and we have turned on the devices and the server, Epic server. All the leaves are running, Epic servers are running. Now, you need to log into the Epic GUI using the default credentials. Now, let's do a detailed study. Wait a minute. Okay, this is also okay. So log into the Epic GUI using the default credentials. Go to Fabric, Inventory, Fabric Membership, and you can begin the setup process. it will start discovering. When you see the serial number, the first device immediately connected leaf, you need to provide a name. Sorry, this is not the, I'm sorry. This is not the switch fabric. This is fabric name. This is not switch name. Sorry. Now you just go to fabric inventory, fabric membership, and you just give a name for the whole ACI fabric. What name you want to give? An organization? No, not organization name. Something like some data center, blah, blah, some name. And then you also need to define the pool. From this pool only, an address will be given to each discovered leaf and spine. And that address is going to act as a tunnel endpoints for VXLAN. So the tunnel endpoint pool is used for internal communication between the fabric nodes via VXLAN tunnel. So no more you are going to configure OSPF or ISIS for the underlay, putting an IP address, setting the routing, none of those things you are not going to do, it's taken care. Those underlay job needs an IP address, that's why you provide a pool here. And once you have done this, Epic uses zero-touch provisioning to auto-discover the connected nodes. That is the second step. See here, you can do both or you can do any one of this. Once the Epic is power on, connected to the out-of-band management, you can do SSH using PuTTY and or you can do HTTPS using a browser, give the username and password, and you log in. And you will see a setup wizard. There you need to provide the fabric name, which I just said here. The same step only in detail you see there. Same point number 2 in detail, this one. Yeah, give a fabric name, a unique name for the entire ACI fabric DC1. And then tunnel endpoint. These are the things that it is going to ask you either through SSH. I have done through SSH, this basic thing, not through HTTPS, but there is also an option you can do through HTTPS. In HTTPS, you will get setup wizard. It's more easy. And then for infrastructure to be up, you need to specify a dedicated VLAN number. So we give a VLAN like 4. VLAN 4 via uses, that's what this VMware people do to bring up VMware fabric. Your wish, you can give any VLAN. Again, don't use that same VLAN anywhere later. Used internally by ACI, whatever you give. Management IP address for the Epic. Also give the IP address for each Epic management IP address, which can be used to do HTTPS. If you want to change the IP other than the default, you need to give. All right, about the pool address. No. For the switches from the, that's what the next page is going to talk actually. What going to be the network from where they get one IP address. So switches, they need an IP address. For that, you have this tunnel endpoint pool that we provide in the initial configuration. Why this tunnel endpoint pool important? The tunnel endpoint pool is used to assign IP address to all ACI nodes. When we say ACI nodes, it is only talking about leaf and spine.
Mhm.
So that the VXLAN can negotiate tunnel between the leaves and do the VXLAN encapsulation. So for the VXLAN outer layer, 3 address is going to be the subnet range which you define. Important note that the tunnel endpoint pool should not overlap with the existing network subnet. So make sure you use a subnet which is not in your production. Okay, third step. So the first step is you connected the physical wires like this. Second step is you created the pool and you gave a name to the fabric. And now the third step is the pool is ready to assign IP address to the switches. Fabric has already got a name. Now the inventory should start, meaning discovery of leaf and spine. So once ACI is configured, it will automatically detect the first switch in the fabric, very first switch will be discovered. For that, you go to fabric, inventory, fabric membership. Go there. When you go there, you will see unregistered switch. You will see their serial numbers with no IP address and name. So what we do is once the Epic detects a new switch, it will list them under the fabric membership. Manually register each switch by assigning a node name like this. Give name. This is leaf 101. This is spine 201. And then you also need to define the role. Is this a leaf or a spine? After giving a name, the role also need to be picked up by us. And then give a name. This is a part of DC1 and it is a leaf. And then click register. Do this for every single node, leaf and spine. After registration, the switch will reboot and join the ACI fabric. That you will see. ACI fabric is not rebooting. Only those switches with a new name, they come online like this. These are the serial numbers. And this is the node ID we gave. We have given this manually. We have given this name manually. And we have given the role manually. Address will be automatically taken. You no need to worry about. You will also see those addresses here. The addresses that are given from the pool. So what happens after registration? Once they're registered, the switch reboots and joins the ACI fabric. Epic assigns the tunnel endpoint IP address from the pool to each node that is already registered. And now the leaf or the switch becomes operational, part of ready to use ACI fabric. Fine, that is step number 3. So far good. Now validate discovery using the Epic GUI. You can also do through CLI. You can also use GUI. Now in GUI, you want to validate whether everything is ready. Go to Fabric, Inventory, Fabric Membership. To check the list of registered node, you will see those like this. You will see a table there. Ensure all nodes show active and registered. And then you come out of it, go to topology view, go to topology view to verify the connectivity between the nodes. So you will see similar to this picture which we did, like this leaf and spine, this fabric. For that, go to, if you want to see the topology view, you need to go to fabric, inventory, and topology to verify all the leaves and spines and whether they are connected correctly. Now, if you want to see the health of each leaf and spine, click on health score to confirm that they are green and 100%. For that, go to fabric health, overall health, ensure health score is close to 100. Now on the CLI also you can verify this, show fabric node and show controllers are the commands. Now through CLI, if you say show fabric node, you will see something like this. The node IDs, names, roles, and the IP address given to each fabric member. Right. You can also verify by using show controllers to see those epics and also to see the adjacent fabric nodes like which leaf I'm connected to. If you want to see from the spine, you can use show fabric adjacency. What to check in this show commands? All nodes should be discovered and registered. Should be having all these things with IP address. All right. So the next step is these are all management stuff. I think we will not focus on this as the next step. The next step is we'll go to the ACI policy model, what it is. We'll talk about authentication, security settings, all the stuff later. Before this, I want to cover first what is policy model. And then only I want to talk about the external connectivity. That is the kind of policy. So let us first focus on ACI policy model. Where do we have all the policies written? On the EPIC. What is ACI policy model? Application-centric infrastructure policy model is a declarative, interact-based model that abstracts the traditional network constraints into a policy-driven framework instead of manually configuring individual devices such as switches, routers, and firewalls. So here, what is policy model? Administrator defines the policy that describes how the application and the workload should be communicated. Here, we don't go to every switches and configure quality of service, VLANs, IP address, who can talk to whom, ACL, etc. things. We don't do like that. Here, everything is an application. That is why we call this application-centric infrastructure. Everything is an application in here. Administrator defines the policy that describes how the applications and the workload should be communicated. A server is talking to another server. Here it is seen as an application, not as a server physical device connecting to a physical port, having some port policy, blah, blah, blah. How application and the workload between the servers, workloads. ACI fabric then automatically enforces this policy, simplifying the network operation, improving scalability, and enhancing security. So through Epic in ACI, we define the policies for each endpoints. Endpoints are identified by either VLANs or IP address, etc. As I said, when the endpoint is connected, as soon as it is connected, automatically the policy is enforced. So you no need to log in and configure after the device is connected. Everything is simplified here because you no need to be there at all. You might have configured policies like 10 months ago. Now someone is connecting, the policy matches, so immediately the policy is applied. The endpoint is matched with the endpoint group, so immediately the policy is applied. Today you no need to be there. You have already put those necessary configuration 10 months back. Simplifying network operations, improving scalability, and enhancing security. So when you remove the device, those policies are withdrawn from there. So there is no blocking of buffer or anything there. Definitely scalability will be improved when you do like that. Only the necessary resource is consumed whenever it is needed. Now, there are key policy components. When you say ACI policy, there are components that we should know before we deep dive into the policies. ACI policy model is based on several hierarchical constructions or constructs. Each plays a critical role in defining how traffic flow within the fabric. Number one, tenant. Number two, bridge domain. Three, endpoint group. Four, contracts. Contracts which will have filters and so on. So let's see one by one. Tenant. A tenant is a logical entity that provides an isolation within the ACI fabric. So ACI fabric is a big resource pool in which a slice of resource with a logical boundary isolating from another tenant on the same shared physical underlay pool. So a tenant can be visualized like an organization which wants to be isolated from another organization, or a department which needs to be isolated from another department, or a customer isolated from another customer. So a tenant helps to have multiple organizations in the same environment. You can call it as multi-tenant environment. ACI is a multi-tenant environment. One physical big fabric with multiple tenants. Each tenant is independent from one another. Each tenant is an isolated boundary. Each tenant can have its own private networks, bridge domains, EPGs, and policies. We are going to see what is this EPG bridge domain in the next page. Now, each tenant can have their own boundaries. That's what it means. They can have their own set of subnets, VLANs, policies, connecting devices, etc. Tenants enable multi-tenancy, allowing different team or customer to share the same physical infrastructure while keeping the network configuration separate. So, though they have one common physical infrastructure, their network configurations are not common. They are separated because they belong to different tenant, multi-tenant. Types of tenants, we have common tenant. This is a very important portion because interview they may ask this. What are the three type of tenants we have? Common tenant, infrastructure tenant, and user-defined tenant. Common tenant is like a shared service container. So you have a tenant which can be shared across user-defined tenants. For example, NTP, Network Time Protocol. It's a service that every tenant needed. So we can put such thing in common tenant so that that NTP service can be shared across all tenants. So common tenant is a shared tenant. We saw in the first paragraph on the top, a tenant is a logical entity that provides isolation. But here, common tenant is not providing isolation, it's a shared one. Secondly, infrastructure tenant. This is also a kind of management tenant, which is only for the fabric to come up. Manages ACI fabric components. Example, span. You want to monitor a port, DHCP, etc. This is for infrastructure. This is not for the users traffic. This is for the infrastructure traffic. For the infrastructure to be up, you need a DHCP to provide IP address for the infra. You want maybe you need span, etc. The next one is the user-defined tenant. This is the tenant which is for customers, and this user-defined tenant can use the common tenant, can also use the infrastructure tenant in some cases. So user-defined tenants creates an administrator created by an administrator for specific business applications like customers. Now that is tenant, the first entity in ACI. The policy component is tenant. The second one is the bridge domain. Bridge domain, you cannot limit this bridge domain within by saying it's like a VLAN. No, that's not correct. Bridge domain, though the word says bridge layer 2. Bridge means layer 2. Bridge domain. Sometimes people misunderstand you with broadcast domain because broadcast domain is also layer 2. One VLAN is one broadcast domain. So bridge domain, immediately they think that it's like a VLAN. Cannot be limited to that small level. Bridge domain is a layer 2 forwarding construct within a tenant. Again, this is another important thing. You see, this is within the tenant. Let me show you a picture. You see this picture here. Tenant is the bigger rectangle inside which you have bridge domain. Inside the bridge domain, inside that blue, you have a lot of small squares called EPGs. Between the EPG, you have contracts, which is the arrow mark. The arrow mark says who can talk to whom. EPG1 can talk to EPG2. you know, endpoint groups. So tenant, bridge domain, EPGs. And contract is nothing but the policy. So a bridge domain is a layer 2 forwarding construct within the tenant. It is responsible for forwarding traffic between the endpoints in the same subnet. Each bridge domain is assigned with one or more subnets and define how the MAC addresses are learned within the ACI fabric. Yeah. So you see, bridge domain is one of the confusing topic. Need to understand this very well. Very clearly, it says it is responsible for forwarding the traffic between endpoints in the same subnet. That is important line that I want to underline, and then I will take you to same subnet, and then I'll say bridge domain have got many subnets. It may have one or more subnets. So will it allow traffic between one subnet to another subnet? No, unless you enable L3, it is not possible, though they are in the same bridge domain. A bridge domain can be assigned with one or more subnets and define. Okay, now let's say you have a VLAN. One VLAN is like one virtual switch. Now, how the MAC addresses are learned by the when a packet arrives from the incoming source address, MAC addresses are learned. How the MAC address of the destination device is learned through ARP flooding. Now, if the intermediate device knows the MAC address, ARP proxy can be done. So all those things are defined here. Each bridge domain can be assigned with one or more subnets and define how the MAC addresses are learned in the ACI fabric. We learned that one in detail when we come to the below paragraph, but let's finish the second one. A bridge domain can operate in different flooding and learning modes, such as optimized or traditional or hardware proxy. Traditional is nothing but it learns the incoming source MAC address. And when an ARP request comes, it is flooded throughout that bridge domain to all, and ARP reply comes. Or hardware proxy, when a host is requesting for an MAC address, if ACI fabric already knows the MAC address, it will give the MAC address instead of the destination giving the MAC address, which is connected in another leaf. Key properties of bridge domain. Unicast routing enables or disables routing for host within the bridge. Within the bridge domain, if you want to enable unicast routing, you can punch that enable or you can disable. ARP flooding. So within the bridge domain, if it is enabled, they're going to talk. You no need to write any policies or contracts for that. ARP flooding determines if ARP request should be flooded or proxy. Unknown unicast mode controls how the unknown destination MAC address is handled. Usually when the unknown destination MAC address, a packet is coming with the destination MAC address which is unknown to the switch, what it used to do is flood. Now what do you want this ACI fabric to do? You want to drop it or flood? Options are available. Next is the bridge domain also defines the IP subnet associated with this bridge domain. The third one is the endpoint groups. Endpoint groups are nothing but the grouping of endpoints such as VMs, that's one group, physical server, another group, containers, another group, etc. Routers, switches, they're also another group. L3, L2 groups. Okay, endpoint groups is a logical group of endpoints that shares common network and security policies. All the VMs will have one common policy. All the physical servers will have one common policy. Endpoint groups are fundamentally building blocks of ACI policy defining how the workload communicates. Endpoint in an EPG can be on different VLANs or VXLANs or subnets as policy enforcement happens at each fabric level rather than the VLAN level. So it is only the VXLAN level, fabric level. EPG is also an important topic to be understood very well. EPG key properties of EPG. EPGs are associated with bridge domain. I showed you in the picture tenant. Inside the tenant we had bridge domain. Inside the bridge domain we had EPGs. EPGs are associated with the bridge domain. Dynamic or static endpoint assignment. EPG can use VLAN or VXLAN or IP based to assign an endpoint dynamically. So depending on your need, when a device is connected to VLAN, you want to identify it as a group of device, as a EPG. Depending on VLAN or IP address or VXLAN ID. Now some device can also send a VXLAN ID. You can extend to the server. So when a server comes with a VXLAN ID, then that will be in another EPG. Contracts defines the communication rule between the EPGs. That's what the next topic is. Contracts are nothing but who can talk to whom. It's like an ACL. This contracts has got subject and filter, subject and filter. Subjects are nothing but who is allowed to talk to whom. Which consumer, who is a consumer and who is a provider here. Who gives and who gets. Can both be a consumer and provider, or one be a consumer, another be a provider? So a contract consists of filters that specifies what type of traffic are allowed between EPGs or denied between EPGs, and which EPG is a consumer and which EPG is a provider. All these things are configured under contract. So how ACI policy model works, the administrator defines the policy, and the policies are stored in EPIC. Very important. Where is the policy stored? That's what the interviewer will ask. It is in the EPIC. Simple. And the ACI fabric translates the policy into hardware-based forwarding rules like data plane rules, like VXLAN encapsulation, with a contract which enforces the communication between the EPGs, ensuring security and traffic control. I don't think it is difficult for you to understand these 4 points. So benefits, we have already seen these benefits in the beginning. Automation. Everything is automated. You're not CLI based. Scalable, secured, and application centric. And this picture I have already explained to you. This also we just saw all these things, right? So